So in this video, we're going to be looking at differentiation, and we're going to start off differentiating by first principles. Now, this video is going to show you a complicated method, and differentiation by rule is a really simple way to do what we're about to do. Unfortunately, the course asks for both. So I'm going to show you the really difficult way first, and then I think you'll appreciate the really simple way more, but you need to be able to do both. So if you remember back to Unit 1A differentiation, we're looking for the rate of change or the slope or the gradient of a given function, okay? And when we differentiate, we're looking at instantaneous gradient. So you remember that we've got the 4 different types: constant, variable, average, and instantaneous. We're looking at the moment at finding instantaneous. So for example, that point there on the graph, we're looking at finding the slope of that point. Okay, so instantaneous rate of change. And we can do that 2 ways. We can do it using first principles, or we can do it by rule. So let me just, I've broken this, find the formula sheet. So we're on page 3 now. Down in the calculus section, we've finished trig. Okay, the definition of a derivative there, that is our first principles formula that we're going to be using in this video. The differentiation one here is differentiation by rule. They both do the same thing, but questions ask for a specific method, so you need to be able to do both. So let's try it. Okay, so first principles, I've got my formula there that's straight off the formula sheet. Okay, and I'm going to use it to differentiate. So there's a couple of little notation things I just want to go through before we start. If you see a function that is y equals, when we find the derivative, you're going to write dy over dx equals. Okay, and that's it's a fancy way of saying rise over run. It's change in y over change in x. The change in y is rise, change of x is run. So rise over run. So the slope is this. Okay, so if the question says y equals, your answer is going to equal dy over dx. If you see a question that gives you f of x, or g of x, or h of x, whatever, your answer is going to be f dash of x. Okay, so just keep in mind that notation. They're both equally used. You might even see, you might even see this, which is the delta symbol means change, a little bit of change. So a little change in y over a little change in x. The D also means delta, which is change in y over change in x. So just be aware of all that fancy notation. It looks very impressive. It's just saying the slope. So same as we used to say m equals for the gradient or the slope, we're now saying dy over dx or f dash x. So just be really aware of that. So you'll need a little bit of patience for this one. This formula can be lengthy, it can be annoying, and it can take a while, but we are going to do our best. So there are a couple of parts here. The first one is f of x plus h, and the second important one is f of x. Okay, we already know what f of x is. So if we did this first one here, that is f of x there. If we wanted to find f of 2, we would sub 2 in everywhere we saw x, and we would do the function that way. This is subbing in, we've seen it before. If we had f of 5, we'd sub 5 in everywhere we saw x. If we had f of 2x, we'd sub 2x in everywhere we saw x. If we had f of x minus 4, we'd sub x minus 4 in everywhere we saw x. So by that theory, what do you reckon f of x plus h is going to be? Okay, it's very similar. Wherever I see an x, I'm going to put x plus h. Okay, so we're looking at this yellow part of the formula. There's many parts to this formula, so we're just going to do this one first. F of x plus h, wherever we see an x, we're going to put x plus h. Okay, we're subbing it in. And then we have to evaluate. Oh, sorry, simplify. We're not evaluating, we're simplifying. So x plus h squared, if you go x squared plus h squared, you have forgotten our entire second unit. We've got to do FOIL. Okay, so we square the first times the second plus 2, square the last. Okay, then this one plus 2x plus 2h plus 3, and I'm just going to have a look through and see if I've got any like terms. Y is an x, that should be a h. No like terms. Okay, so that is f of x plus h. Do you see how it's lengthy? Okay, but whatever function we get, wherever we see an x, we're going to sub in an x plus h to give the function of x plus h. Okay, so this one here would go in there. This one here would go in there, and h would stay where it is. Okay, so this is a lengthy process, but I promise you'll laugh when you see the shortcut. So we're going to do a bit of an easier function, and we're going to do the function f of x equals 5x plus 7. And we're going to find f dash x. Okay, so we're going to find the equation of the instantaneous slope by differentiating. So lots of big words in there. So we're going to use first principles. So we've got a couple of things to find. We've already got f of x there. What we need to find is f of x plus h. So what was originally x is going to be swapped to be x plus h. So it's going to be 5x plus h plus 7. And I'm going to expand that out and collect like terms, which in this case there are none. Okay, and then I'm going to pop it all together. So the limit as h approaches 0, and we'll talk about that in a minute. So f of x plus h is 5x plus 5h plus 7. Okay, take f of x, which is 5x plus 7. One of the most common mistakes is people won't put them in brackets, and they'll only take away the 5 and they'll still add the 7. You need to make sure that you're taking away that whole function. Okay, so let's have a look if we expand it out. So 5x plus 5h plus 7, whoop, take 5x, take 7. You can do this in one step as long as you don't forget to take away the 7. We're going to collect like terms. So on the top we've got 5x and we take away 5x, they cancel out. We add 7 and we take 7, so they cancel out, and we're left with 5h divided by h. Now if you've got one term on the top and one term on the bottom, you can simplify. If you have two terms on the bottom, you've got to take it out of each term, so just be really careful about that. So the limit as h approaches 0, 5h divided by h is just 5. Okay, so the limit of the function f of x equals 5x plus 7 is 5. Okay, so lots to take in there. Okay, and if I was following my own rules, you could also write it like this: f dash x equals 5. Okay, so that one was a pretty simple one. I'm now going to take you through a really annoying one just to show you what they get like. And that's this one here. So f of x equals 6x minus 2x squared. And you might think that's not too bad, but we've got a bit of expanding to do. So I'm going to do them color coordinated. And I'm going to start with the easiest one, which is f of x. So f of x is already there for me. That one's fine. F of x plus h. So I need to sub in x plus h wherever I see an x. And I need to simplify. So this first one's fine, 6x plus 6h. This one here, minus 2, I've got to square those brackets, so x squared plus 2xh plus h squared. Then I've got to distribute the 2 with the negative. Okay, you've got to be really careful. Not the big mistakes, but the common mistakes are forgetting those negatives. Okay, have I got any like terms there? No, I don't. So that's f of x plus h. Okay, now let's put it together. So I've got f of x plus h. So I've got 6x plus 6h minus 2x squared minus 4xh minus 2h squared minus 6x minus 2x squared. And I'm going to distribute those brackets now because I don't want to write it again. So minus 6x plus 2x squared. 2 negatives make a positive. And that is all over h. Okay. Now I'm going to go through and I'm going to collect my like terms and I'm going to try and simplify. So I've got 6x there. I've got take away 6x. So 6x take 6x is nothing. I've got minus 2x squared plus 2x squared, so they cancel out. And I am left with 6h minus 4xh minus 2h squared all over h. Now, you might start to pick up a pattern once you do a couple of these yourself, and that is that all the terms that don't have a h should drop out. That's not to say that you should just look at it and cross out all the terms that don't have a h, because it's often a really good way to pick up your mistakes. So if you're left with an x, just a plain x in there somewhere, not attached to a h, that's an indicator that something's gone wrong somewhere. So check your brackets, check your expanding. So here I can take a h out of all of those terms. So I can take 1 out of there, 1 out of there, and 1 out of there, which would leave me with 6 minus 4x minus 2h. Okay, and if I'll just rewrite that. I'll put it with a proper notation. Six minus 4x. Okay, and here's where the trick comes in. So in the last one, they kind of cancelled down to get a number. Okay, we got 5, and that's great. And that will happen often. Sometimes you will also be left with x's in there, but you shouldn't be left with any h's. So what we're going to do is we're going to have a look at this limit here. And we want to know about this function when h is getting really close to 0. And we're going to do that by subbing in 0 for h. So 6 take 4x, 2 times 0 is just 0. So f of x, in this case, f dash x, I'll just reorder it, is negative 4x plus 6. Okay, so you can see that they go from quite simple to quite annoying very quickly. You can also see the one we did there before can get annoying as well, but it's good practice with your algebra. So start off easy, make sure you've got the concepts right, and then move on to the harder ones. Next theory lesson, I'll be showing a shortcut, and you will be able to look at that and in 2 seconds flat be able to do it. So don't lose hope. This is fiddly and annoying, but I promise you there's an easier way.